to take out the GCF. First, we had to take out that 3x. And then this 2x squared minus x minus 15 factored more. It factored further. It factored to 2x plus 5 times x minus 3. Now, this type of factoring is something that we all should be able to do without help. Okay, so if we're not there yet, let's just keep working. Just let's get there before Tuesday. Okay, so I'll show you up here what you do with that. So we'll make the big X. 2 times the negative 15 is negative 30. What can we multiply to get negative 30x that we can add to get negative 1x? Negative 6x and positive 5x. So we're going to take that 2x squared minus x minus 15 and split this. Alright, let me go ahead and say, those of you that can do trial and error and factor this straight from here to here, please don't stop. Keep doing it that way. This takes a lot longer. Alright, what do these two have in common? A 2 and an x. And it leaves me x minus 3. So over here I want an x minus 3 left. Whatever I get here has got to match. So what do I factor out of this second group?
5.
That's right. So we pull the 2x minus 3 out. We group the 2x plus 5. And because we pulled the GCF out to start with, we have to leave it in front. So here's this is a degree of 3. It has 1, 2, 3 factors. Okay, now this one is easy. You can tell the x is 0. This one is easy. You can tell it's 3. How do we get this negative 5 halves? What do we do with this one? Okay, what we do is we set it equal to 0 and solve. So when there's a leading coefficient, you set it equal to 0 and solve. And there's one like that on the homework tonight. That's why I did that on purpose. Okay, first power, passes through, no squiggle. No inflection points at any of the x-intercepts. Alright, so let's look at number 5. And I'm going to factor it with you. This is what it factors to. But let's see what we need to do to get there. So if I multiply the first term and the last term, I get 4x to the 4th and negative 5x squared. So what can I multiply to get positive 4x to the 4th? And I can add to get negative 5, negative 4x squared, and negative 1x squared. So we're going to take the middle term, which was negative 5x squared, and we're going to break it into negative 4x squared and negative 1x squared. Okay, if we look at the first two, we pull out an x squared. And when we do, it leaves us x squared minus 4. So here I want x squared minus 4, so I have to factor out a negative 1. So this gives me x squared minus 4 times x squared minus 1.
Does it have to be in that order or no?
No.
Okay.
So this one is a difference of squares. So it factors to x plus 2 times x minus 2. This one right here is also a difference of squares. It factors to x plus 1 and x minus 1. So this one has 1, 2, 3, 4. 4 factors. And each of the factors is only raised to the first power, so does it pass, 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 pass? Yes. All right. This one's already factored for us. We didn't even have to factor. So when we have this factored form, negative 2x squared, x plus 4, x minus 4. This first term, what can I plug into the first term here that would give me a 0? 0. What can I plug in here? Negative 4. What can I plug in here? Positive 4. So we would start plotting those. Negative 4, 0, positive 4. Now, because this is squared, at the 0, it's going to bounce. At the negative 4, it's going to pass because it's to the first power. At the positive 4, it's going to pass because it's through the first power. Do you see how it passes, bounces, passes? We're only looking at what's happening at the x-intercept for this bounce and pass. Got it? All right. So those of you that got it, you just take that worksheet you picked up today and you just boogie right through it.
Yes, ma'am.
Okay? Those of you that could benefit from seeing a couple more done, you just keep watching, keep asking questions. Okay? So this is today's worksheet. X to the 4th minus 25x. The first thing we have to do, if the problem is not factored, we have to factor it. What is the GCF for this problem?
X squared.
X squared. So we're going to take out the x squared. Okay? When we factor out the x squared, what are we left with? X squared minus 25. Okay, so this x squared minus 25 factors some more. What does it factor to? X plus 5? X minus 5.
Why?
Alright, so that gives me my x-intercepts. When it asks for x-intercepts, we should really write them in as ordered pairs. But I'm just going to write what the x values are. With the squared one, x squared, what's the x-intercept that goes with that?
0.
0. With the x plus 5, what's the x-intercept?
Negative 5.
Negative 5. And with the x minus 5, what's the x-intercept?
Positive 5.
Positive 5. So let's put those on here. We'll put one at negative 5, at 0, and at positive 5. Okay, now we're going to figure out what's going on with our ends. We have x to the 4th. It is a 4th degree function, and the leading coefficient is positive. Even and positive. Even and positive. What are the ends doing?
They're both going up.
They're both going up. You're so right. There's my ends. They're going up. Okay, now let's draw in what's happening just at the x-axis. B. At the negative 5, this one was raised to the first power. So what's it going to do here, guys?
Pass through.
Pass through. Okay, so now I went from this side, I'm down here. At the 0, the 0 is squared, so it is going to bounce. So it's going to touch and bounce back, touch and bounce back. So I'm still down below the x-axis. And at the positive 5, it's going to pass through. All right, so now let's just connect it. So it goes to where it passes through. We'll loop it around, and it connects. Oh, that was terrible. There we go. Okay, so the end behavior was as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y does too. take a 3 out. I'm actually going to take a negative 3 out. Why?
Change the sign.
It makes that first term positive,
That's
doesn't
the
it?
leading coefficient.
Yeah. We want that leading one to be positive. So if we factor out a negative 3, now I've got x to the third plus 5x squared minus 4x minus 20. Okay. If we have 4 terms, what do we try? We try to group them. So we're going to group the first 2, and then we'll group the second 2. Alright, in that first group, what's the GCF? X squared. And it leaves me x plus 5. So over here, I want to be left with x plus 5. So what can I factor out of that second group? A 4. But we need it to be negative to change the signs. So this gives me x plus 5 times x squared minus 4. When I put these two together, well, what can we do with x squared minus 4? Yep, it keeps going to the plus and minus. So it's x plus 2, x minus 2, and we can't forget that negative 3 we pulled out to start with. Alright, there's no x with that negative 3 though. It's just a number. So it doesn't give me an x-intercept. I only get x-intercepts where there's x's. So my first x-intercept is negative 5, 0. My next one is negative 2, 0. And my last one is 2, 0. So I've got x-intercepts at negative 5, negative 2, and 2. Yes, Cole.
How'd you get 3?
Yeah, that's what I was wondering.
Uh-huh.
How'd you get the 3 on the factors?
We factored the negative 3 out to start with.
Yeah, I know that. But how'd you get 3 parentheses?
Because x squared minus 4 factors some more.
Oh.
That's
Okay.
2.
Huh? She factored the negative 4.
Yeah.
Okay, so the degree of this function is 3, and it has a negative leading coefficient. So when I come over here and put one at negative 5, and then another one at negative 2, and then another x-intercept at positive 2. If I have a negative leading coefficient and it's an odd degree, that means it's going to rise to the left. That was supposed to be an arrow, and it turned into a blob. And fall to the right. Okay, each one of these factors is just raised to the first power. 1, 1, 1. So, will it pass, bounce, or squiggle? Pass. When they're raised to the first power, it's going to pass through. So it needs to pass through, then pass through, then pass through. Just straight old passing through. And then we just connect it.
Sorry.
Yeah.
Why did the negative 3 not do anything in the...
Okay, the negative did do something. The negative
So
made
leading
the end behavior go from like this for an odd function to this.
Right, but it's not a...
Okay,
It's
so
not
that's what the
intercept.
negative did. Now, the 3, what that
This is on the
causes is just a vertical stretch. So if you graph this on the calculator, what you're going to notice is these humps, the max and min, are actually really stretched out. This one's way down low and this one's way up high. But since we don't care about that, it doesn't matter.
But on the first one, the x squared was
Yeah, because it's an x. It's
But-
an x.
Yeah, this one had an x, so it gave us the 0. This one doesn't have the x with it. just -3.
So it doesn't
So there's-
matter at all.
it
Or
doesn't
does.
give
It
us
doesn't
a-
matter, but it doesn't give you a intercept.
You're right.
Okay.
It does matter, but it doesn't give you an intercept.
Okay.
Perfect. Yes, ma'am.
Why in number 1 was it not 1 instead of 0? Because I thought there's always an understood 1.
What we could do anytime we have just an x by itself, that's x squared. And you're right, it is 1x squared. But we could write it like this. Anytime we have like an x squared, we could write it as x minus 0 squared.
Okay.
And so that
So it just
very
always
first
goes up?
packet we did that on every single problem that had just an x. Yes, sir.
The back of this is kind of like I'm confused
Okay.
as to what to do.
Okay. Well, as soon as I finish number 3, I'm going to go over the back.
Okay.
That is it. See, next is number 7. Did you catch that?
Yeah.
Alright, so number 3 has to be factored. It has to be factored. Okay, if you're hanging out with me, I want you to try to start factoring this one on your own.
What does it want?
This one's passing. This one's squiggling. And this one's just.
Big dog.
So, if I were to go and write this as a factor, it has to be the opposite. Plus 5, half, first power. Plus 2, pass through, first power. X minus 1, yep, and x minus 4. Squared, because it passed. Now, I really should have left some space up in front to write y equals. And because the end behavior rises to the left and falls to the right, and that's what you're supposed to get out of there. So,
So what's the one
this
here?
A, I wrote right here.
Okay.
We identified our roots.
Yes, ma'am.
We talked about whether it passed or bounced.
Okay.
Your pencil is just like mine. And this is actually, yes, it would, yeah.
Well, I didn't hear the same thing.
The rest of that is
Cube.
I ignore that.
Okay, guys, those of you that are working ahead, tonight's assignment is to finish up the worksheet that I'm going over with everybody right now. The packet we're gonna finish up tomorrow. Alright, so let's take a look. Let's see how you did. We're gonna factor out an x cubed. And when we do, we're left with 2x squared minus 9x plus 9. So if we think about what can we multiply to get 18x squared that we can add to get negative 9x, did you guys get negative 6x and negative 3x?
Ah.
Yes!
Ah.
Okay, so we're going to split this into negative 6x and negative 3x. And then we're going to group. So a 2x comes out. It leaves me with x minus 3. We want x minus 3, so we pull out the negative 3. So that gives us x minus 3 times 2x minus 3. But we can't forget the GCF that came out to start with. So when I list all of my factors, it's x cubed times x minus 3 times 2x minus 3. Alright, so this one gives me an x-intercept at 0. This one gives me an x-intercept at 3. And what do I do to find this x-intercept for the factor 2x minus 3? Can we set it equal to 0 and solve?
Yep.
We sure can. so x equals 3 halves, which is just 1.5.
So it wouldn't be negative? Sure, never mind, my fault.
Alright, so 1, 2, 3 is good enough. I have a 0 at 0. I have an x-intercept at 0, an x-intercept at 1.5, and an x-intercept at 3. Alright, so I'm going to come back over here and check out the degree of the function, which is 5. Now I can look for the 5 here, or I can count it here. 3 plus 1 plus 1 is 5. Whichever one you're most comfortable with. And then the leading coefficient, we have a positive leading coefficient. So that means it's going to fall to the left and rise to the right.
Like why?
I thought that was an even number. So you do rise, rise.
5?
Oh, never mind.
Okay.
I was looking at 2.
Still
All right.
confused.
So let's look at the 0. The x-intercept at 0 came from a factor that was to the third power. Third power. Pass through, bounce, or squiggle.
Just squiggle.
Squiggle.
I have a question.
Yes.
So the 5, when you add them all together, that's what tells you where the arrows go.
Uh-huh.
Right?
Mhm.
And then the 3 is what tells you what squiggles.
The 3, yes. These individual ones tell me whether it squiggles, passes, or bounces.
Okay.
All right. 1.5.
Pass through.
Pass.
Pass through.
And then pass. All right, so let's finish connecting them. So this is gonna whoop, whoop. Now, normally I don't separate it, but I just wanted y'all to see specifically that this pounce, bounce. Let me try that again. Pass, bounce, or squiggle is really just looking at the x-intercepts. That's why I broke it up like that. Okay. This last one, number 7, is the last one I want us to do. Okay, so let's look at all of our x-intercepts. Let's list our roots right here. This is 1, 2, 3, 4, negative 5. What is this one? Negative 2. What is this one? 1. And what is the last one? 4. Okay, so it said to identify the roots. Done. Then it says to describe the root behavior. Is it tangent? That means does it bounce? Or does it pass through? Now with pass through, we say pass through, or there's an inflection point. So this one just passes through. This one just passes through, but this one squiggles. It has that inflection. We got a squiggle there. And what happens at 4?
Tangent.
It's tangent, so it bounces. Okay, good. So now let's write the function. Y equals, and I'm going to leave a little space because I have to come back at the end to decide if it's positive or negative. If negative 5 is my x-intercept, what is my factor?
Positive 5.
Positive 5, x plus 5. That passed, so it's to the first. So if negative 2 is my x-intercept, what is my factor?
Plus 2.
X plus 2. It passed, so it's to the first. If positive 1 is my x-intercept, what's my factor?
X minus 1.
Okay, now this one squiggles,
To the third power.
so it needs to be at least to the third. Alright, and then 4 becomes x minus 4, but this one bounced, so it's squared.
2 or b.
Alright, so let's count. 2, 5, 6, 7. This is a 7th degree polynomial. Alright, and it rises to the left and falls to the right. So that has to have a negative leading coefficient, doesn't it? So what we need to do, because of the end behavior, we have to put that negative in there. Oh, I just wrote this on the wrong line. All of this should be on this line. Whoopsie. That is a polynomial. But do you see how to write it? Okay. Alright, let's see what you can do. This really should pick up speed once we get used to what we're doing.